In this lesson, you will identify linear equations, intercepts, and zeros, and then we'll also graph some linear equations. So here's your vocabulary. A linear equation is an equation in the form ax plus by equals c, whose graph is a straight line. So what I want you to notice is there's 1 power of x, 1 power of y. This is not an x squared or a y squared. To make it linear, it has to be just 1 power. I could have just a y, and that would be a horizontal line, which I'll show you in a little bit, or it could be just an x, which I can show you in a little bit. That's a vertical line. But you definitely have 1 power of both variables. Standard form of a linear equation is ax plus by equals c. So you have to have the x first, then the y, and then the constant. A has to be greater than 0. A and b have to both be not 0. And a, b, and c have to be integers. So that means no fractions or decimals whose greatest common factor is 1. So you can't have a common factor here. So when we write it, we have to write it in this order to be standard form, and we can't have a common factor. And I'll show you some examples of that in a moment. An x-intercept is the coordinate at which a graph intersects the x-axis, and a y-intercept is the coordinate at which a graph intersects the y-axis. And we're going to be using intercepts to do some graphing in a moment here. So look at this linear equation, or is it not linear? We have to decide. Well, let's put it in standard form if we can. Do we have 1 power of x? Yes. 1 power of y? Yes. So we are going to say that yes, this is, and we are going to add the 3x over. So we would get 3x. We're going to subtract, or this is the y, so we do plus y equals 4. So now you can see it's ax plus by equals c. We don't have a common factor. We have no fractions or decimals, so this is good standard form for this linear equation. All right, this example, do we have 1 power of x? Yes. Oh no, look here. X and y are being multiplied together here. This is not just a y. So this is not a linear equation. This is a no. And so you don't have to worry about putting it in standard form because it's not even a linear equation. This example, do we have 1 power of y? Yes. But look, this is an x to the power of 2. X squared is not a linear equation because it's a power of 2. So we just put no. And we don't have to worry about standard form because it's not linear. This example, do I have 1 power y? Yes. And there is no x value here, but remember I said that was okay? That's okay. So this is a yes. Now, to put this in standard form, since we don't have an x, that's okay. You don't need to have one. But look here, there's a fraction. So what I want to do is multiply everything by this denominator, which is 3. And so a third of 3 is just going to be 1, so this will be y equals, and then negative 1 times 3 would be negative 3. And this would be a horizontal line at negative 3. So yes, this is linear because it makes a horizontal line at negative 3. I'll just do a quick sketch of that. Here's origin. So this is 1, 2, 3. Here's negative 3. This is what this line would look like right here. It's just a horizontal at negative 3. So x and y intercepts. This is the y-axis. So where is this line here crossing the y-axis? It would be at this point here. So you count 1, 2, 3, 4, 5, 6. So you could say that the y-intercept, I better make this intercept here. The y-intercept is 6. Or you could actually put the coordinate here, which would be 0, 6. Either one is fine for y-intercept. The x-intercept would be right here. And so we count 1, 2, 3, 4, 5, 6, 7. So we would say the x-intercept is 7, or you could actually have the coordinate here, which is 7, 0. Either one would be fine. So this particular graph, the x-intercept is here, y-intercept is here. How about this graph? This is the x-axis here, so we're looking at this line right here. Well, it has a y-intercept here, so we'll say y-intercept is at 1, 2, 3, 4. Or you could put the coordinate here if you wanted to, which is 0, 4. And then the x-intercept, if you will look here, this is a horizontal line, so it will never cross the x-axis, so you would say none. And that will happen sometimes in a linear equation. It won't go across both axes. Now, a real-world problem, this is a table that has time in the x column and volume in gallons in the y column. And what happens is we have a full swimming pool, and we're going to drain this pool at a rate of 720 gallons per hour. So the table shows how much water is in the pool at that time. So you can see at 0 time, 0x, we have 10,000 gallons. So let's just count by 2,000s here. So it's 2, 4, 6, 8. Here's 10,000 gallons right here, approximately. So this is a full pool. And then we have, if we count by 2s, at 2, it's about 8,000. And then at 4 or 6, actually, it's about 5,000. And then 2, 4, 6, 8, here's 10, which is a little more than 2,000. And then 12. And then at 14, it's at 0. So it's approximately linear, but not exactly linear. Now, the x and y intercepts, if we graph this, we would say that that's more linear. We could. The y-intercept is here. The x-intercept is here. So what do these mean? Well, the y-intercept is about 10,080 gallons. So that means that this is at 0 time when the pool is full, like our starting time when we have a full pool. This x-intercept, if you will look here, is at 14 hours. We have an empty pool. The pool has been completely drained. So in this real world example, the intercepts are very important because it tells us our starting point and our finishing point, and we actually would not have to graph beyond these. It would just be a line segment because you can't have less than 0 gallons and you can't go backwards in time. So it would just be this section. So the intercepts are very important in this situation. And intercepts are very important in graphing as well. Let me show you. This particular linear equation we can graph. And if you wanted to figure out what coordinates, you would have to do an XY table and a lot of guess and check. Well, we can use the intercepts and it'll go a little bit faster. If I wanted to know what the x-intercept was here, that's going to be when y is 0. So you will find the x-intercept when y is 0. So we would have 2x equals 16. Why did I skip this? Well, because 4 times 0 would be 0. And so it's just 2x plus 0, which is 2x. Divide by 2, and we get x is equal to 8. So 1, 2, 3, 4, 5, 6, 7, 8. This is my x-intercept at 8. Now we can find the y-intercept. Well, that's when x is 0. This will be when x is 0. So I'm going to do the same thing as I did earlier. Just leave this x out because 2 times 0 is 0. 0 plus 4y. And then I would solve for y. And I get y equals 4. So there's my y equals 4. Now this is a linear equation, so I can draw a line. I have a ruler, and I connect these 2 points, and then I draw my line. Now I definitely want you to use a ruler on your assignment. Obviously it's harder to do on a smartboard, but I just graphed this using the intercepts, and that's a shortcut that you can use. Now could you still do an XY table? Absolutely. You can just plug values in. In fact, that's what we're going to do here. So I want to draw a line here for y equals 1/3 x plus 2. I recommend trying maybe 3 points or 3 x values. So I'm going to do obviously maybe -3, 0, and 3 just because I'm working with a fraction of a third just to make it easier. So I have a third of -3, well, that's going to be -1 plus 2 is 1. 0 plus 2 obviously is 2. And a third of 3 is 1, 1 plus 2 is 3. So this is -3, 1, 0, 2, and 3, 3. And now that I have those 3 coordinates, you can just connect them with a ruler and draw your line. So like I said, try 3. I will have this one in your notes for you to try. I want to show you a couple examples here. If this is just an x, then this is going to be a vertical line because I have no y values. So here's 1, 2, 3, and this will be a vertical line right here on 3. If it has just a y, then this is what we call a horizontal line, and that's because it has no x values, and this is at -2, and so we would draw a horizontal line at -2. So if you have just an x equals, it's vertical, just a y equals, it's horizontal. But I would have you graph one in your notes.